Welcome to this panel discussion on improving program insights through data integration and interoperability. So in the last decade, we seem to have transitioned from a paucity of data to being inundated with it. There are multiple systems being leveraged for reporting aggregated data, for reporting services at point of care, or that vital last mile and hard to reach beneficiary information. The narrative has gradually shifted over the years from incentivizing increased reporting rates to developing robust quality assurance protocols for accurate, meaningful, and actionable data. The undeniable reality on the ground is the multiplicity of tools and systems being used for program management. The current challenge this presents is the inability to conduct a 360 analysis based on all available data as opposed to system-specific or a siloed view. So our panelists today from FHI 360, Jhpiego and BAO Systems will discuss their approach to addressing this challenge in order to provide holistic analysis for better programmatic insight. And introducing our panelists, we have Amina Abagana, a business solutions manager for FHI 360. She leads the programmatic solutions team with the FHI's within the FHI's Information Solutions and Services Department. Amina has for the past few years been leading FHI's analytics for health initiatives, which focuses on combining the expertise of strategic information and technology experts to provide sustainable solutions that harness the power of data for action and impact. And also joining us from FHI 360 is Siaka Momo, who is an application analyst. Siaka is an engineer and an ICT professional with over 12 years experience in system administration, software development, database management, monitoring, and evaluation. He manages FHI 360's enterprise data warehouse and also provides database management support to other FHI 360 country projects. Now on the Jhpiego side, we have Scott Merritt, a senior health informatics advisor working on systematic analysis of health information systems needs, development, customization of those systems, and structuring data associated with these systems. Currently, Scott supports Jhpiego's enterprise DHIS2 instance, well, actually multiple instances, and is also helping to expand their information systems footprint so that each of the 40 country offices have a DHIS2 instance. I wonder how he has not lost his hair already, but you know, such is the mettle of the man. I do have to say that the recent award-winning blockbuster movie Nomad Land was partially based on Scott's life, as he has lived in several sub-Saharan African countries, including South Africa, Zimbabwe, Botswana, Angola, and Nigeria. Now, I'm only joking, but you know, he must be a dodgy character if he's lived in all these countries over the years. And now, well, anyways, sorry, just messing with Scott. for BAO Systems, we have Catherine Liu wearing multiple hats. As one was director of business development, but also the analytics product platform product owner for BAO Systems. Catherine is a veteran public health professional with almost 2 decades of experience in M&E, health informatics, and data analytics. Having worked in multiple countries across Asia and Africa, she has a deep appreciation for our partners' data needs. Catherine builds and maintains partner relationships, conducts market research, and recommends impactful digital solutions. Last but not the least, a man who probably does not need any introduction, Lars Helge Overland, is the Chief Data Officer and co-founder at BAO Systems. He's a software engineer and architect with many years of experience building web and integration solutions. He brings a deep expertise in systems architecture, databases, data modeling, data analytics, and the web API design. Just in case you did not know already, he has been the lead developer of Jhpiego, now the world's largest information system within international development domain since inception in 2005. I am absolutely just excited to hear what the panelists today will be sharing. And as we go through their presentations, BAO will start and hand over to Jhpiego, and then please do use the Q&A feature, and we will take questions at the end. So we'll be handing over to BAO Systems.
Thank you.
Thanks, Basoy. Good morning, good afternoon, and good evening, everyone, and thank you for the session today. Like Basoy mentioned, my name is Catherine Liu, and I'm joined by Lars Overland, our Chief Data Officer. And today we're going to discuss some of the key challenges that we've observed our partners facing and how BAO Systems is working with our partners to overcome them. For those of you who aren't familiar with BAO Systems, we're a team with diverse skills and expertise that enable us to help our partners use data to drive programmatic impact. We support our partners throughout the entire data lifecycle, from defining analytic questions and strategy to point-of-service data collection, organizing and aligning data across information systems to advance analytics and machine learning so that decision makers have the data they need to improve programming. Within an HIS, or a health information system ecosystem, we know that there are a multitude of systems and tools being implemented, which are used by governments, implementing partners, and donors. But the question is, how do we create replicable processes for integrating data across these systems at scale to improve the rigor and effectiveness of data analysis and use? Some of the approaches currently being used are the use of the OpenHIE framework, which has come with some implementation challenges, development of bespoke connectors between systems, but often falls short of addressing the entire HIS ecosystem within a country or within an organization, independent file exports, CSV file exports from each system, and then analysis of those data files using SPSS, Tableau, or other BI tools of choice, as well as scalable data warehousing architecture, which is really the focus of today's panel, whether based on DHIS2, SQL, Postgres, or other platforms. In addition to data integration challenges, there's an increasing need to conduct more meaningful analytics to give us more insights into our data, which really gets to the point as to why we want to integrate the data in the first place. In looking at multiple HIV/AIDS program indicators, for example, we observe a seasonality. For example, the PMTCT EID tests that are performed. While advanced analytics will not tell you the cause for those peaks and troughs, it can help you better understand when you are observing an unexpected spike and dip in service delivery based on previous year's data. Similarly, performing predictive analytics can tell us what the expected result is. Combined with the ability to conduct predictive analytics together with trend analysis, this would enable us to much more effectively understand our programmatic data. And again, this is really the whole point as to why we're developing solutions to integrate our data across different sources. BAO Systems sought to address these challenges by designing a platform that would enable, first, the ingestion of data across systems and tools commonly used in the health and development sector, which we'll get into a little bit later. Secondly, to improve access to public global data sets that are already available but not easily accessible in order to enrich data analysis by providing richer context. Thirdly, we wanted to offer a scalable data warehousing solution where systems aren't already in place by an organization or government. And lastly, we realized the importance of being able to make all of these data available for advanced analysis, visualization using popular BI tools that are commonly used amongst our partners. There's a number of off-the-shelf data integration and warehousing platforms on the market, including from popular cloud service providers such as Amazon Web Services and Microsoft Azure, among others, that enable ingestion of various data sources. Some of the challenges that prevent governments and NGOs from adopting these existing solutions include cost concerns with highly customized solutions that may not scale, the need for IT staff to design and manage the solution, limited access and/or complexity of use of the system for program and M&E staff who do not have backgrounds in IT, and most importantly, the absence of data connectors for data collection and management systems and tools that are most often used within the global development sector, such as DHIS2, ODK-based tools, such as ONA and Kobo Toolbox, ComCare, Medic Mobile, Dharma, and others. In addition to this, the various public data sources that I alluded to earlier. We conceptualized the BAO Analytics platform to meet our partners where they are in terms of digital maturity. We have a number of pre-built connectors that have been designed with an understanding of how data are used within our programs and are continuing to build out more. For governments and NGOs that lack pre-existing robust systems, we offer end-to-end packaging of data ingestion, warehousing, and data availability in leading business intelligence or visualization tools. For those already using AWS or Azure, our solution enhances the existing enterprise architecture through our pre-built connectors, reducing the number of custom tools that need to be developed and maintained by an organization or government themselves. Ultimately, the goal of our platform is to enable users to bring their own data, regardless of the system or tool, together into a central repository where it can be cataloged, aligned, archived, and then used for analysis. I mentioned earlier access to public data sets. In this digital era, numerous data sets from various different sectors that are relevant for health programming are already available, but not easily accessible to those without a technical background in data science. For organizations and ministries of health that do have data science capacity, staff are often inundated with M&E requests and find it challenging to find the time to identify, curate, and prepare these data for analysis. We wanted to enhance our partners' ability to use these varied data sets for triangulation by enabling one-click ingestion into the BAO Analytics platform. We continue to identify, curate, and make available relevant data sources across multiple sectors, including population and demographics, health, nutrition, water and sanitation, agriculture and food security, and weather, as well as COVID-related data. Ultimately, better access to these data will enable M&E staff to better and more holistically analyze their own data and answer questions such as, how does deforestation and population spread affect the emergence and resurgence of disease? What are the discrete geographic areas where we are most likely to see a surge of neglected tropical diseases? And how does weather pattern and seasonality affect disease patterns? What effect does differing perceptions on the severity of COVID-19 have on the disease spread within a community? And what malhealth and disease patterns can we expect and where from anticipated droughts and/or flooding? These are some of the questions that we are seeking to help our partners to understand, and by making these data sets more available within the platform shown here, we're hoping that it will be a lot easier for organizations to answer some of these questions. Through the use of our platform, we also aim to bring about increased data access within an organization or country by improving workflow efficiencies. For example, within a country, organization, or project, key data are collected using ComCare and DHIS2. In addition, there's a variety of COVID surveillance data that are available through our open data library. Imagine this organization where M&E staff and other data analysts use a collection of analytic and visualization tools such as Power BI, Tableau, and ArcGIS. And I think this is common for most of our organizations where there isn't a single tool of choice that is used 100% throughout an organization, as each M&E staff or each stakeholder has their preferred tool of choice and need to model and shape and use the data in different ways to display it for different insights. Within the platform, a super user can join two distinct data sets together, say by country name. The new join table can then be made available together with the original data tables more broadly amongst the data analysts and M&E staff, meaning that they don't have to duplicate efforts to transform the data across the organization. Through access controls and by table, each analyst can use their tool of choice in order to analyze and visualize the data that they need to make the decisions for their program as relevant. So now I'm going to hand it over to Lars, who's actually going to take us through a demo of the analytics platform before coming back and showcasing some of the analyses that we've helped to perform.
All right. So hi, everyone. Let me just share my screen. Can you see my screen now? Many of them, I guess.
Yeah, many of them.
All right, so I'm going to give you a very quick demo of the platform that we built at BAO, and Catherine has put the introduction well. So the BAO Data Analytics platform is essentially a platform for data cataloging and for data integration. And as some of you know, like a data catalog is really a system for cataloging and describing and tagging data in order to make it easily discoverable by everyone in the organization, so that every sort of data consumer in an organization can know which data sets and assets are available in the organization. It also allows you to search for data sets and also to provide access control around the data so that you can give appropriate access to the people that need it. The platform is also about data integration, as Catherine said. So we've built connectors to a lot of the systems that you will see in the national development space. So you'll see connectors to everything you see on the screen now, which is ComCare, CSV files, which is still very popular. There's DSAT2 is quite prevalent, as you know. There's Kobo, Toolbox, ODK, ONA, and also different databases like SQL Server, Oracle, Postgres for more sort of bespoke solutions that exist out there. We're also going to touch on the public data sets as well. So the system basically allows you to point to these different systems and perform transformation, and then ingest the data into a data warehouse of choice. And currently we support both the Amazon clouds, and the data warehouse there is Redshift. And we also support the Microsoft Azure cloud, and the data warehouse there is called Synapse Analytics. So we've made it really easy to sort of get an overview of your data sets. You can search for data sets by putting it here. You can search by the different sources, so I can filter by the different sources. We can have a look at some of the connectors. For instance, if you would like to connect to ONA, that is a very simple thing to do. We can create a new one. I can show you what it looks like. So to connect to an ONA instance, everything you have to do is to give a name, refresh schedule, meaning how often do you like to refresh the system. We can provide different metadata tags, and then we have the connection information, essentially just the link to the API of ONA, which is this, and then what we call an authorization token, which is just the kind of access key that you have for your project. And then you can define the form that you want. In this case, it's just one, but this would normally be populated with more forms. And finally, you specify the data warehouse target, as we call it. Basically, which schema and which table or tables do you like this data to end up with in Redshift? And then it does everything. So once you click save, this is then automatically going to pull all the data from your ONA form and put it into the data warehouse, and also keep it up to date so that this is constantly being refreshed, and so that your data is kind of fresh at all times. We can have a look at another one, a DSAT2 connector. So we've connected in this case to one of the DSAT instances that hold COVID-19 data. So again, we give it a name, description. We can have an owner. You can also tag the data based on what you want. We can put in different tags to make it easy to find the data later and classify it. And then for DSAT2, it's a bit more involved. You have to enter the database credentials. So it's the host name for the database, database name, username, password. So we use a direct connection to the database because DSAT2 can have sometimes sort of large data volumes. We also use the web API to pull out the metadata like datasets and programs and so on. So you also need to set up a credentials to the web API, like the base URL, a username and a password to the API. Then you can select the data type. You can choose between aggregate data, different programs, and you also have metadata tables that you can pull in. And finally, you define the target in the data warehouse, the schema and the table name that you would like to use. So again, once you click save, this is then automatically gonna refresh. So that is basically it. It's very simple to use, and it allows you then to pull in data from all the different systems, and it allows you to have all of your data from these different M&E systems in a single place for analysis. Yeah, I'm going to touch on quickly a couple of the other features that we have. So from a data catalog perspective, we have a data preview. So this basically gives you the top 50 rows of the data set, so you can quickly go in and see what the data set contains, just to give you an idea about what it is. We have a data structure, which basically gives you a profile about the data. So for every field or column, we have the data type, number of distinct values, null values, min and max, and so on. So this is just to give you an idea about what columns and what data fields exist in this data set. In terms of transformation, so far we support using SQL statements. This follows the paradigm that someone you know calls ELT, which means extract, load, and then transform, which means you basically transform the data once it is in the data warehouse, which is sort of the modern trend in data pipelining and data integration. So this allows you to write SQL statements that you can apply to the data once it's in a staging table. So we first pull the data into staging table. You can apply different statements to transform the data, and then finally the system will change the staging table to become the production table. So with the modern data warehouses, this is a quite powerful approach because you can handle large-scale data in a declarative way with SQL. Yeah, we also have a change log, so you can go here to see what's going on with the data set, like if there was any failures, last time it loaded, the log of previous sort of ingest processes, and so on and so on. So you can see, what's been going on with this data set. Yeah, there's a couple of other things. So we also have the ability to control access. So a problem in data warehousing is that it's a bit complicated to give granular access control. So many people end up with just giving kind of a super user access to everything, which is not great in case you have a more complex organization where people are supposed to only see certain parts of the data. So in this case, we can decide to keep this data set private, share with everyone, or share with selected users. In this case, you can then select whatever user you would like to give access to this data set and then save it.
Yeah. 1 minute.
1 minute, yes. So we can also download the data. We can, if you'd like to get access in locally, they can download the data from file and then use it in different types of data processing tools that you have on your desktop. We also support views, so you can write custom views on top of this data set, and this is what's very helpful when you would like to join data sets, and the data sets can be quite complex. So if you would like to create these kind of complex joins, this is a good place to do it. And this becomes a view in the warehouse, which means then everyone else can then just consume the view without having to know the complex joins that sits behind it. Yeah, and then the connection information tab is essentially where you go to understand how to connect to the system. So it explains which provider it is. In this case, it's Redshift and Amazon. It has the host name, port, database, username, and the password is the same as you use for this platform, so it's easy to access. So in most BI tools today, like Tableau and Power BI and so on, they all have connectors to Redshift and Azure. So you can just take this information and easily connect. So once you do all this, it's very easy to create all the visualizations. For instance, you can connect from a database management tool, and then you can browse the tables, you can browse the columns and everything in your warehouse to understand what's there. And it's also very easy to open up with, let's say, Power BI and create nice visualizations like this, where we now have a very simple way of querying all the data, providing visualizations in Power BI or desktop or Tableau, depending on your organizational needs, and then create nice dashboards and analytics based on all of your data in an integrated way. Yeah. So I'll stop there. That was the quick and dirty overview. Over.
Thank you very much. And now Scott from Jhpiego. Please do remember to turn your video on as well as you start to present, Scott.
Yeah, hi everybody. So following up on all of the things that Lars and Catherine have spoken about, I wanted to give you a quick story about how Jhpiego is leveraging these tools, and to talk about how for Momentum Country and Global Leadership, or MCGL as I will be referring to it, how we've taken the platform and all of the examples that Lars is talking about, and how we're spinning differently to tell or to work on telling much more of a health system strengthening story than a lot of the historical uses that we've seen of a lot of this, and a lot of what people think about was just service delivery. So just quickly about MCGL and Momentum. Momentum is this large suite of awards. We have the project that's trying to work on technical capacity development and assistance, building government-led partnerships, and doing a lot of strengthening of the countries that are slightly further ahead or closer to goals of development. With all of that, as we work on all of that, we work across a wide variety of countries in a wide variety of technical areas as we're trying to work on the journey to self-reliance. And as we attempt to do all of this, we realized that we wanted a platform that could help us to tell the story more broadly of what we were trying to do. But at the same time, as I said before, note that this is much more on the health system strengthening than it is on the service delivery or service delivery, direct service delivery and service delivery implementation support. So with all of that, not to get too deep into the weeds, but what we did was we've been thinking, how do we think about the journey to self-reliance? How do we work on all of that? How do we think about supporting that? And to all of those ends, we have this theory of change. And not to get into any of the details of it, but in particular, that thing at the top, that's impact. That's what we care about. That's what we want to be judged on. Either we had some or we didn't. Then we have this thing that is traditionally counted, service statistics and the amount of services and traditional service delivery coverage, service delivery quality, all of those sorts of things is what's traditionally counted. But the reality for us is the way that we wanted to tell our story is about all of this other stuff. And all of these things are, health system strengthening related. Not to get too deep into it, but, we want to talk about equity gaps and technical rigor and adaptive management and partnerships. And that is where we approached BAO and said, hey, this is what we're trying to do. Do you guys have any ideas, any thoughts on what we could do and how we could start working on it? And so as we were talking with them, we realized that fundamentally we're talking about three things. There is the traditional HMIS data and information that we have. This is historically, when we've done projects, this is what we try and do, and we try and do more of it, and we try and do better. And as we get inundated with data, as Bisoy was mentioning in the introduction, we thought that while this is important, and so we certainly collect information like, how many doses of DPT-3 we had and how many newborns died before discharge. that isn't all of the information that we wanted as we were working on telling the MCGL story. And but realistically, as we thought about this, this is the types of quantitative information that we wanted to load into the analytics platform. And traditionally, most of this is going to be programmatic information that goes into our DHIS2. We are trying as hard as possible in MCGL to collect from the ministry's national HMISs and load through all of those processes that everybody knows about. But along with all of that, we had this other thing that we very much wanted to count as well. All of that stuff on the fat bottom of the theory of change. It's very much about HSS. I've talked to a lot of data people, and the data people tell me, oh my goodness, those indicators are boring. And we can't deny it. I mean, the challenge is historically, and as we've been working on all of this, when we think about data at a much more granular level, as close to the end user on the ground as possible, in as small of a geographic region as possible. And the reality is there's a lot of thought about, just how can we collect more farther, closer to the end user. That in traditional M&E speak is exciting. What we are talking about with HSS is boring, and I have to fully grant that and explain where we're coming from. The other challenge with a lot of what we want to count is reporting on donor timelines. I feel like companies on Wall Street that have to report quarterly earnings, but the things that we're trying to measure should be measured in years and not days or weeks or even quarters. Those things aren't in sync, and we're working on figuring out the ways that we can see if our health system strengthening is happening on that kind of a time frame. Finally, the other challenges we've had with what we wanted to collect is that largely a lot of this data comes from Word files, PDFs, things that are sitting on SharePoint. So we started a process of tagging those so that we could incorporate them with the rest of our data. And we'll talk about that a little bit when we get to the dashboard. So we do, these boring indicators, partnership strengthening plans developed, or country representatives serving as active members of Target Global Technical Leadership Fora. These are the kinds of things that we can measure and count, and we can share with our donors in the way that has been traditional. But what we also very much wanted to do, and what we wanted as we were working on this dashboard, is we wanted to work on showing and telling the story of the long-term questions. How can we tell a story about whether or not participatory design and planning leads to more effective implementation? That is a crazy nuanced question. It's difficult. It's going to involve a lot of different data sources, a lot of different information, and that's what we're working on. So along with the quantitative information that we were talking about on the previous slide, we have called this our complementary qualitative information set. As we were thinking about that, and as we want to get to try and talk about counting what really matters, which is the impact at the very top of our theory of change, we realized there was yet one more data set. And so Lars has already talked about it, Catherine's already talked about it, their publicly cultivated data set that we're leveraging as well, in the hopes that when we do the work on MCGL, we'll be able to see not just results on the programmatic level where we can prove that something happened, but if we really had impact, hopefully we'll be able to see movement in DHS numbers, in stuff like that, that is, the SARAs, the mixes, the big independent things. That's what we're trying to measure. And so we would like to include that in the dashboards that we were developing. At the same point, we're in a global pandemic dealing with all of these challenges. And so we also wanted to bring in other baseline information that sets the context, rainfall, populations, COVID cases, all of that sort of stuff. And so what we've done is we've called that, our global data tentpole. So those three types of data sources, of which we have several of each type, all come together to hopefully help us tell the story of whether or not our project is going to be a success. And ideally, what we wanted to do is have our dashboard help us to explain the process of not just whether or not we were a success on these things, but even in the ideal world, we'd be talking about why. Why were we a success, or why weren't we a success? We think that to be a true success at MCGL, whether or not we can see impact at the global level might be a big question. But if we can really be strong and understand with all of the countries that we're working on, why or why not did the things that we thought would work, that is our truest definition of success. And we wanted a dashboard that could try and help to elucidate some of those questions and that information. And so what did we do? We, after spending a lot of time talking to BAO and working with them, we thought that we could leverage the analytics platform to bring all of the information that we were talking about together to try and work towards telling those stories. And in our case, we're visualizing it all in Power BI dashboards. Along with the three data sources, the three types of data that we're bringing together, once we started thinking about the needs of the dashboard, we realized that at the same point, we also have three fundamental ways that people think about the data and that we needed to think about for our audience as to how to visualize this. Us on the M&E team, very much think about this in terms of the theory of change. Are the big questions that we're trying to answer, how does the data tie to all of those? And are we getting results or aren't we? But we also know that we have traditionally technical advisors that think about their technical area, and we have program officers that think about their country. And what we've wanted to do is to make sure that while you come at any of these questions from your particular mind space, we still allow you to cross-reference all of the other data because it all comes from the same data source. To do this, what we've done is to create an initial navigation screen, which is in your top left, where you pick whether or not you want to view your data by country, by technical area, or by the theory of change. And then you see the corresponding sub-navigation pane, which gets you towards the places where you want to be. Theory of change on the bottom, technical area top right, countries in the bottom right. When you click on one of those things, you get to one of the various data tabs that we have created. We are working as hard as we can to see how much we can parameterize versus figuring out how for each question we need to make different tabs that work on addressing all of those. What you can see in the top left is a page where we're talking about capacity. This is the page that we're talking about for service utilization. That's one of our accelerators, and people can look and see, that here's the data that goes with that. In the bottom, we've created more traditional tabs that focus on all of our family planning data, where you can flip through the various questions. We do have notes about the various accelerators at the top, in the top center. And again, we have filters and allow you to dive through and all of the traditional stuff. And then finally, in the top right corner, we have a country page. The thing about this that we find the most interesting as we've been working on all of this is what we call the human learning part, as opposed to the machine learning aspect of this in the top right. We have gone through all of our files on SharePoint and we've tagged them. And so in this case, if you've picked Ghana, this top right section will give you links to what are all of the pertinent information and pieces of data that we have about Ghana. If you want to narrow that down by a given accelerator, for instance, if we're talking about equity in Ghana, again, all of that stuff can filter down as we work on all of this. So realistically, just to wrap up, I mean, we're super excited about all of this, but realistically, telling stories about HSS, it's really hard. Every country is so distinct. There's the different mix of parameters and all of that stuff. When we're a global project trying to tell these stories, it's tough. And people don't really think like this. So, if you can have all of the data that you ever wanted, what would you pick? It's too hard to get your mind around, so you give up. But on the other hand, oftentimes, you're always like, oh, wait, just this one more thing and just this one more thing. And then you've gotten so deep in the weeds that you've lost the generalization. It's hard. And so with that, as we said, no amount of data is ever enough. And then just the process of mapping from all of these sources together, it's terrible, but it's getting less so. And so we're excited about all of this. And thank you for your time. And now we'll move over to FHI.
Hi, everyone. I'm Meredith Mahaji. I'm a data management colleague of Amina and Siaka. And so that we would not fall victim to a spotty internet connection, I'm going to go ahead and present some pre-recorded audio and video on slides that Siaka and Amina did.
Hi everyone, my name is Amina and I am here to share FHI 360's experience with improving program insights through data integration and interoperability. This presentation will be focusing on our PEPFAR programs, starting with the need the organization tried to address, an overview of the system built to provide solution, application and use of that system, and my colleague Siaka will briefly take us through the technical process for establishing data integration. This effort started with the need to consolidate data at the global level in order to have greater technical oversight of country programs. This was characterized by higher frequency reporting, so a shift from quarterly reporting to monthly and weekly reporting, as well as more granular level of reporting. So higher, finer disaggregations of data elements being reported, as well as reporting at the facility and community levels in order to enable us or facilitate early course correction. The organization also wanted the ability to integrate data sets from routine program data with other data sets such as financial data, so we can gain insights that can help improve program quality and produce more efficient models for service delivery while being responsive, more responsive to funders, and in what is known to be a constantly changing environment. There's also a desire to facilitate south-to-south learning between our country programs, and we wanted to do all this without the any additional burden of data entry on our program staff. I am now going to talk about the system we built to address these needs, which is part of the organization's enterprise data warehouse, EDW, based on Microsoft technology and tools. The choice of Microsoft was based on the fact that the organization has an existing not-for-profit licensing agreement with Microsoft, which provides access to their technology and tools at an affordable rate. This diagram here depicts the PEPFAR component of the EDW. Before I get into it, I would like to say the first step in this process was for us to establish a standard definition for indicators and reporting units at the global level. This was necessary because even though we are pulling data from PEPFAR programs, the way the projects may have defined indicators and data elements and reporting units in their database may differ from project to project. So to enable standard analysis at a global level, we had to define a standard for these at the global level as well, which the project could map to. Back to the diagram, in terms of establishing a connection, we established connections to existing databases with that our projects are using for reporting routine data. A number of our projects use DHIS2 for reporting, and for those we establish connections via the API. We have a few projects that use Access or a custom-built application with a MySQL backend, and for those we connect to views within the databases. And then we have one or two projects that report using Excel, and for those we upload those files to SharePoint in order to establish a connection. Along with the data sources, we ask the projects to complete a mapping template, which basically contains information on how data elements and reporting units are represented at source, which is the project databases, and they are required to map that to the standard we have at the target, which is the global level. This exercise is done using Excel tables at the moment, but we are actually thinking about representing the mapping information in the project databases so that we can just get that information when we're pulling the data, and we don't have to ask the projects to complete this manual mapping process. After we have the data source and the mapping files, it goes into this middle box, the automated data processing, which is a bit of a black box for non-developers. And I'm not going to talk so much about it because my colleague Siaka will be going into details about what happens here. But basically, we ingest the data using a number of tools and then carry out transformations using stored procedures within SQL database. And the final results are tables and views we can connect to using Power BI, which is our go-to BI tool as an organization. But you can also connect using other BI tools or just export to Excel. And from the reports in Power BI, any other tool, you can pull the visuals into your PowerPoint presentations. When it comes to application and use, the organization uses information from this system to review project performance and take decisions based on data presented at senior management meetings. Technical teams also regularly review this data to inform areas they need to focus on in providing technical assistance to country programs. The ability to compare performance by different projects for different program areas at the global level also promotes learning between our country programs. We also use this data to inform proposal development, and this data is also used widely to serve multiple donor requests, and the data is also used in data and reports are also used in presentations, papers, and conferences. I'm going to hand over to my colleague Siaka, who will take us through some technical examples on how we establish data integration. Thank you.
Okay, so here we look at the actual implementation of the technologies, how we employ the technologies to achieve this data integration effort. We use 4 major Azure cloud services for this integration effort. One is the Logic app, the second one is the data lake, the third one is Azure Data Factory, and the fourth one is SQL Server. We're starting with the Logic app here. As you can see, the Logic app has different stages. Now, the Logic app is used to connect to the various data sources, be it Excel, be it a database, be it an API to pull down the data from there. Now, in our own case, we're connected to an API, the Jhpiego data source via the API. The first part here you see is the recurrence section. In this recurrence function, we use it to set the frequency at which the Logic app executes. It could be once in a day, it could be once in a week, it could be 2 times in a day, and so on, just as you desire. You use the recurrence section to do that. The second bar here is the HTTP function. We use this one to connect to the data source, in this case the Jhpiego, to pull down the desired data. Okay, so the third bar here is the upload section, and that is the data lake. Once the data is pulled from the second bar, it's now stored on a location on the Azure cloud services called the data lake. So we upload that data, that is the third bar. Now, once this is done, we repeat this for the organization unit. We do the same circle goes for the data element, the same circle goes for the category combinations. And then we'll move down to the read data set values itself. Now, to get the data set values, we'll put out the data set values by month. And so we may desire to put out the data set values, let's say, for about the past 10 months. Now, what we've done is to create such records in the SQL Server table, and then we retrieve that record to the Logic app via the get rows function of the Logic app. Once that is done, for each function loops over that record and then pulls down the data per month and store them on the data lake. This is what the Logic app is for. Now, so looking at it in detail here, this is where we set the recurrence section, and you can see the interval there. The first one here is you can see interval is 1, and the frequency is day. That means we are saying that it should execute once every day. And then at this hour, so at what hours do we want to execute? At 1 p.m. So the setting here is saying that execute this Logic at 1 p.m. every day. So that's what this the setting shows. Okay, here we look at the HTTP function in more detail. We look at how it is configured. As you can see, it has a method section which we set to get. This is to tell the function how it's going to connect to the API. The URI section, we use it to set the URI, that's the address of the HIS2 that we want to connect to. As you can see in this URI, we're trying to get the organization units metadata. So it ends with organization units .csv, and we're getting it in CSV function. Other areas here that we look at, the headers, the queries are not so necessary, but the next part is the username, which is we put in the username that for your HIS2, and then the password, we put in the password that you have. So that's once you are done, you're done with that, this ends this configuration for the HTTP function. Now, when that data is pulled, as in the previous step, it comes down in a file called the orgunits.csv. This is on the configuration that we have made, and that file is stored on the data lake here. So what we have here is just a location of the data lake where we store whatever we pull from external data sources. In this case, now the HIS2. Now, once the data is pulled pulled and stored on the data lake, we connect that file to what we call the external table on the SQL server or here. And once that connection enables us now to view the content of that file directly in the table on the SQL server. So what you are seeing here is just a table, a snapshot of a table that is connected to that orgunit.csv file, showing the various columns there. There are just 3 columns: the name of the orgunit, which is in this case now the facilities, health facilities, the ID as it is on the DHIS2, the source where we got it from, and the organization unit part, the part which indicates the parent and so on, all in IDs. So this is exactly the content of that orgunit.csv file that we showed you earlier. Here we use Azure Data Factory to create the pipelines. These pipelines are used to execute the various procedures that were already created in SQL Server. Now, as you can see, there are various stages here. The first is datum to curated. And at this stage, we move the data from what we call the datum folder to the curated folder, all on the data lake. This is mainly for cleanup. Then when we now move to the next stage, datum DCC mapping. This is where we map the datum element. There's a mapping file that has already been created and placed there. Then we map the data, the datum ID or names to that of the project names. The next stage is data element category. Here we process the data element ID and the names together as it comes from the source. The first stage is organization unit. Here we process the organization unit ID and map it to the names. The fifth stage is the datum mapping. Here we are actually looking at processing the mechanism here. The mechanism here refers to the names of the projects that actually own the data. So once we are able to do this, we are able to tell where the data is coming from. And once these 5 processes are done, it moves into the final table we call the fact monthly data set values table, where it can now be outputted to for further processing. Okay, from the previous stage, we get to this final stage where we have the data in the final table, structured the way we want it. The key fields we actually need are here. We have the data element ID, the period where the data is generated, the category combination, the data element names, who stored the data in the source, and even the values they are here. We also have the mechanism. The mechanism, as we said earlier, represents the name of the project where the data is coming from. That way, we're able to filter or do analysis per project and whatever we need to do with it. Now, so this is what we have. From here, we can connect any data visualization software like Tableau, like Power BI, even Excel, we can connect to this. Even GIS, we can connect to this and then get the data out for display and for program implementation and planning. So thank you very much. This is all we have for this. Thank you.
That's thank you so much to our panelists for such engaging discussion on and presentation on interoperability and integration and the different approaches that you have all gone through. Sadly, we do not have a lot of time for questions, and I know there's a couple of questions already in the Q&A. So I think I would ask this question to perhaps Jhpiego first, and this would be: what level of technical capacity is required to actually set up this platform? What have you found in terms of sustainability and being able to do this in-house without external support?
The good news is that the tools are becoming a lot less sophisticated, and the analytics platform helps take care of a lot of the extremely technical bits. But with that said, there's still a significant amount of skills that are required to bring this all together. And what we've learned, though, is the hardest part is honing in on what is the best information to use on a given question. There, when you have so many opportunities and so many possibilities, that is much harder to figure out which questions to answer than to figure out how to answer them, being that we have so much data.
Yeah, and perhaps maybe I would open this up to FHI first, and Jhpiego maybe just ready with a 20-second answer. Is what were the main drivers for creating this platform for integration and interoperability? Was it cost? Was it efficiency? What was it for FHI that led you to invest in this integration piece? So FHI.
Yeah, thanks, Musoy. So like I mentioned, for us, it was that need to have greater technical oversight of the country programs, and make sure that we were analyzing our data at the most granular level and being more proactive in our programming rather than being reactive. And in terms of selecting the platform, efficiency definitely was a key thing we considered, and then also cost, which is why we keyed into the existing licensing agreement we had with Microsoft, which gave us the platform at an affordable rate. Thanks.
Excellent. And Scott, what about for Jhpiego? What was the driving factor?
Yeah, I mean, we definitely wanted to leverage the tools that already existed in the, I mean, that's why we use as much DHIS2 as we do. So to leverage the platform. But the challenge for us is that we felt like we were going to be very limited in our ability to answer these broad global health system strengthening challenges without the data integration that we've been looking for.
No, great. Now, for everyone else who needs to ask questions, you can find these individual panelists from the People's tab and send your questions to them or connect with them or link with them outside just this session. But unfortunately, that is all we would have time for at the moment, as we're over the hour. But thank you once again to our illustrious panelists. Enjoy the rest of the session.